Hello, everybody. Welcome to the second session of Python. The first session of Python was about basics of Python. We talked about how to create variables, how to create lists, how to create and use dictionaries, and then a few other items like how to work with functions, how to create loops, and we talked about if, else if, and conditions and different things. In this session, we want to talk about how we can use different libraries in Python. Now, the first library that we want to use is called NumPy. If you have downloaded Python from Anaconda distribution, NumPy comes with it. So it's NumPy is pre-installed. But each time that you reset your Python, in order to be able to use this, you must run this code. So import NumPy as NP. Again, execute this code one more time. When you want to execute, you can just do F9, which is on Mac, you have to hold Fn button down and then click F9. And then on Windows, just click F9. So first we do this. When you execute this line, import NumPy as NP, it just in your console, you can see that, but nothing happens. Yes. Now, let's just review lists so let's say we create a list like this. I want to call this list like my list. So we are here, we are creating a list. Yes. So here we are creating a list. And then add here, I want to ask Python to display our list, ask Python to display our list. I call this list my list. So I'm here asking Python to do this. And Python shows this is a list 10.5, -2, 13, 0, 5.2. And I can ask Python what's the type of this, and it gives you it's a list. And as you remember, we did a lot of things. For example, extract. If I want to extract 13, I can do this. So in Python, counting starts from 0. So 10.5 is element index 0. -2 is element index 1. 13 is element index 2. So my underscore list, and then inside bracket 2 gives us this 13. Yes. Now, if I want to, for example, extract now, as a practice, please do this, extract 10.5. Stop the video. Again, whenever you see this @ sign, please, whenever you see this @ stop the video, try this yourself. And then when you're done, just play back the video. So the answer to this is this. Again, name the list, which is my underscore list. And then inside brackets, the index for that, the index for the first element is just 0. So my underscore list 0, and then run it, and you get 10.5. Yes. Now let's say we want to convert this list to an array. All you got to do is this np.array, and then inside parentheses my list, and you get this result. It's gonna be array. So what's happening here? NP stands, so here we imported NumPy as NP. Yes, therefore we need this NP. And then NP is a library inside Python that has many things. It's very good for working with arrays. So np.array, and then inside parentheses, you name the list. It converts that list to an array. And so here, just note that we didn't change the list. We just displayed the array version of this list. Yes. If you want to actually create an array off of a list or convert a list to an array, you got to do this. Yes. So here I want to call this array ARR or R. And then, so I say R equals np.array inside parentheses, my list. And then this is a variable. I can ask Python to display this R and it shows this for me. And I can ask Python what's the type of this. And when I ask Python what's the type of R, it tells me it's a NumPy.nd array, n-dimensional array. So that was one example. Let's move to the second example. So remember that in Python we could have nested lists, yes? Nested list, a nested list is a list of lists, yes? So something like this, I have a list of lists. So this list has 1, 2, 3, 4 elements. Each element is a list, and each inside list includes 3 items. I call that list 2. So here I can run this. And obviously, if I want, I can ask Python to display this list for me. Display list 2. How can I do that? Just all you gotta do is to say list 2 and then run the code, and Python does it. Now, as a practice, please do this. Extract -8. So negative is right here. Stop the video and please do this yourself. So extract -8. So for that, first of all, you have to find like what element we are talking about. This is element index 0, index 1, index 2, index 3. So I'm going to say list 2 and then index 0, 1, 2, 3. Yes. But if I run this, I'm going to get the whole thing that I have here from here to here. So now list 2 inside bracket 3, that's a list. I can extract each element of that list that I want. If I want -8, that's element index 0 of that. So I'm going to say list 2, 3, and then inside another bracket, 0. Yes. So this is just a practice of what we had before. Now, can I convert this list 2 to convert list 2 to, let's say, an array? Yes, of course. How? Like before. So I'm going to call this R2, and R2 is going to be np.array list2. And I ask Python to display that. And this is the output that I get. So I see that I have 3 rows. Yes, each rows are the horizontal and columns are verticals. I have 4 rows and I have 3 columns. Type of this R2 is, again, NumPy NP array. I can use dot shape. Yes. So dot shape is attributes. I can use dot shape attributes. So attributes. And it tells me the attributes, like how many, the R2.shape tells me how many rows I have and how many columns I have. So here I have 4 rows and 3 columns. We can easily get a transpose of a matrix. So here, this is 4 by 3, a matrix. Yes, we have 4 rows and 3 columns. I can get the transpose of that. So what is a transpose? It's rows become columns and columns become rows. So here, the first row, 1, 3.2, and 8, it became the first column. Second row became second column. Third row became third column. And fourth row, -8, 8, and 2 became a fourth column. So just as a reminder, let's see the difference between functions, methods, and attributes. So similarities and differences between these three. So when you have a method, let's say methods, usually you have some object and then dot name of method, so object dot method, and then parentheses. Attributes don't need parentheses. Functions, first you mention the name of the function and then inside the parentheses, the object that you have. For example, these are predefined functions that we have, like type of 35, and you get int as integer. Length of ABCD, you get 4, yes, because it's the length for that 4 is 4. And then methods are like these, like swoosh.upper. It converts everything in upper case, and that dot lower converts everything to lower case, and then arr dot transpose, it just transposes everything as we just saw. And then attributes, just like dot shape, it gives you the shape, or like how many rows and how many columns we have. Just remember, attributes don't need parentheses. So you remember we had this range function. Yes, we had the range function before, and the range function, the way that it worked, it was like in first part of Python basic, we got to know range function, and it had either 2 or 3 arguments: start, stop, and step. And we remember that start was inclusive, stop was exclusive, and step, the default was 1. So we have exactly the same thing here, but rather than range, we have something called NP arrange. Yes. So, but it's exactly the same thing. Arrange work as like this: np.arrange, and then start, stop, step. And again, start is inclusive, stop is exclusive, and step by default is 1. So if you don't include that, that's going to be 1. If you include it, it's going to be the number that you want. For example, let's say 5 and 9. So let's have all the examples of these by each other. And then maybe I change that number from 3 to maybe -2, huh? And it's a better example. So here we had these like before. So range 5 to 9, it goes up 1 at a time, and 5 is inclusive, 9 is exclusive, so it stops at 8. Next example that we had before was -2, for example, to 10, increments by 3. So -2, 1, 4, 7. Yes, and 10 is exclusive. And then their array equivalents. Yes. So these are their array equivalents. If you want to do an array of like that, these are the solutions. So we can create arrays like that. Okay, now again, please pause the video, solve these 2 questions yourself, and after that, continue solving this. So question number 1 is provide an array of all 2-digit odd numbers. So when we do that, we want the result to be something like this. So we want the result all 2-digit odd numbers. So it's going to be 11, 13, 15, all the way to 99. Yes. So that should be your result. And then the second question asks you to provide an array of all integers between 20 and 50, which are divisible by 50. Yes, all integers between 20 and 50. Let's say inclusive. Inclusive, which are divisible by 5. So that the result is going to be something like this. Yes. 20, 25, 30, 35, 40, 45, and 50. So create this, as a matter of fact, that's the question. How can we do that? Again, using arrays, not so. Again, pause the video here and solve it. So question one, the answer is going to be something like this. So if I want to provide all this, I'm going to say np.arrange. So something that a big mistake that students always do is this np.arrange. And then they, for example, they say, let's say the answer is going to be from 11 and all the way to 100 and then 2, yes. And then they run this and they get this. NumPy has no attribute arrange. So just that what's going on here? NP doesn't have, like, again, NP has just here arrange has only one R, yes, not two R's. I know the word arrange has, like in English, has two R's, but here for NP, no, it's just one R. And then NP, just imagine the word range and then a range, yes. And but NP dot arrange, that's gonna be the correct answer, and it gives you array of all odd numbers from 11 all the way to 99. So that's the answer. Next one, we want to do this np dot arrange, and then the answer is going to be from, let's say, 20. Again, I shouldn't go all the way to 50. If I go to 50 and I say, like, step is 5 and I run this, 50 itself is not included, so I get up to 41. So I should go maybe 51 or 52, or yes, a little bit further, and then we get the answer. Okay, so next question, an array of 5 zeros. If you want to create this with the keyword dot zeros, you can do this. So np dot zeros 5, you can create 5 zeros, for example. We used tuples before, yes. So a tuple is a collection of objects with ordered, which are ordered and immutable. Immutable just means unchangeable, yes. For example, if I ask Python what's the type of this, it tells me it's a tuple. We can pass in tuples and get an array or matrix as well, yes. So for example, here np this, you get again array, and here you get a matrix, yes. So rather than list, you can pass in tuples and you get the same results. If you, sometimes we want to create like a matrices like this, np.zeros 2 by 3. If you have comma between them, yes. Here, what we are gonna get is a matrix of 2 by 3, 2 rows, 3 columns of zeros. So that's one thing. Sometimes you want to, so these are like very important in Python, because in many cases you want to start with a zero array and then just add different numbers to that. Or if you want to do ones, you can, rather than zeros, you just say np.ones. So if you want just 3 ones, you do np.ones 3. And if you want a 3 by 4 matrix of all ones, you do this, np.ones 3 by 4. In Python, remember, like, we can't add numbers to lists. However, we can add numbers to arrays. So remember, something like this gives us an error, like let's say -5 and then 0 and then 9.5, 9.3 plus, for example, a number 8, yes? And when you run this, Python tells you only can concatenate list, not integer to a list. So you can't add numbers to list. However, so remember this. Remember, we couldn't add numbers to lists. However, we can add numbers to matrices or arrays. However, we can add numbers to arrays. How? Like this. So np dot, let's say np dot ones. So here we have one more example, np dot ones, and then 2 comma 3, and oops, I have two s's right there. Okay, let's run this one. Okay, what mistake did I make? I need two parentheses. One of them is the tuple inside, and then two parentheses. So np.ones, 2 and 3, it's a matrix of 2 by 3 of all the ones. Then if I want to, for example, take that one and add number 50 to that, I can easily do that. Number 50 is added to each element of this matrix. So I get 51, 51, 51, 51, 51, 51. Or you can multiply or divide them by a number. Yes. Again, we can't do this with lists, but we can do this by arrays. Yes, or here I'm dividing all them now ones by 20. We can easily create something called identity matrix. Identity matrix is a matrix that has 0 ones on the main diagonal and all other elements are zeros. So identity matrix of size 3, which means 3 rows and 3 columns. All you need is np.I and then 3. Okay. Next application, very important application that we have for NP, for NumPy is this, to create random numbers. Yes, we can easily create random numbers with NumPy. So there are a few different items, but one of the most important ones is uniform distribution. Yes, creating random numbers, for that we use something called np.random. And then depends on the kind of random number, we have to add something else. But for all of them, we do np.random. So we have three main ones: uniform distribution, normal distribution, and random integers. Let's just talk about each of them. For example, if I want to do something like this, if I want to create something from uniform distribution, uniform just np.random.rand is what gives us an array of n numbers from uniform distribution between 0 and 1. So if I do, for example, np.random.rand and then 1, it just creates one random number between 0 and 1. If I want, for example, three random numbers between 0 and 1. So here, three random numbers between 0 and 1. I do this, np dot random dot rand 3. What was the definition of uniform distribution? Uniform distribution means every number between 0 and 1 has exactly the same probability of getting chosen. So all numbers have exactly the same probability. Now, if you want to create a matrix of, let's say, random numbers between 0 and 1 from uniform from uniform distribution, we do something like this: np.random.rand, and then inside parentheses, you just say 4 and 2. The important thing is that do not pass it tuple. Yes, just separate them by comma. So it's going to be unlike this one, like np.ones. We, as a matter of fact, we needed a tuple inside, so we needed two parentheses, open two parentheses, close two parentheses. And here you just open one parentheses, you separate them by comma, and you close that parentheses. And obviously, needless to say, the number of parentheses that you open, you must close the same number of parentheses. But np.random.rand creates these like 4 by 2 matrix of random numbers. Perfect. So that was uniform distribution. The second one that we have is a normal distribution. Normal distribution, we have something like this. Normal distribution is a bell-shaped distribution. I try to do that with my, let's say, mouse here, yes. But normal distribution, for that we use something called np.random.randn. So if you prefer the standard normal distribution, use np.random.randn. Standard normal distribution is a bell-shaped as has a mean of 0 and variance of 1. So if you want only one random number, you do this np.random.randn, and then inside parentheses 1. If you want 3 random numbers from normal distribution, you do this. And if you want a matrix of 4 by 2, you do np.random.rand and 4 by 2. If you want, so that was standard normal distribution, which has a mean of 0 and variance of 1. If you want to, for example, have another mean and variance, we can do something like this, yes? np.random.normal, and then have the mean, comma, variance, comma, size. So for example, here I want just one random number. Let's say you want a random numbers from normal distribution with mean 3 and variance 2. So I want only, for example, one random number. I say np.random.normal, and then we say, for example, 3 comma 2 comma 1. And it comes from normal distribution with mean 3 and variance 2. If you want 4 numbers from that, do this. So create an array of 4 numbers from normal distribution with mean 4, with mean 3 and variance 2. We do this. Yes, np.random.normal, and then 3 comma 2 comma then the size, which is 4. If you want a matrix of 5 by 4 from same normal distribution, we do this. We get a matrix of 5 by 4. Last one, if you want to create a random integer, this is also very practical and very useful. So if you want a random integer number, you use this np.random.randint, low, high, size, and high is exclusive, yes? So again, high is exclusive, and then low is inclusive, yes, as always. So I'm gonna write this down. Always, like in Python, the first number is inclusive, low is inclusive, comma, high is exclusive. So if you want, for example, only one random number from between 10 and 20, we do this. Or for example, you can say this. That also, so this gives you an array. This gives you just a one number. So here an output is the output is a random number between 10 inclusive and 20 exclusive. So 10 is inclusive. If I do the same thing, but here I mention, for example, this one is 1. I get, for example, the same thing, but in form of array. If I want 3 numbers, not 3 numbers, I do this. Here we go. I got an array of 3 numbers. And then, for example, we can do this as well. Let's say we want a 5 by 4. Yes. That gives me a matrix of 5 by 4. Yes. So here we got 3 numbers. And here we got a matrix of 5 by 4 random numbers. Again, between 10 and 20. And then each time that we do this, we get different numbers. When you run this code, you're going to get different numbers than what I do. It's absolutely normal. As a matter of fact, if you get exactly same numbers, I'll be really, really surprised. Okay, now we have a few questions here. Please stop the video, pause the video, and then solve these questions yourself. And then when you're done, just let's check continue the video. Yes. So the first question, create an array of 5 numbers from uniform distribution. So what I'm going to say is this: np.random.rand and then 5. Second one, create a matrix of 2 by 3 from uniform distribution. Just the same thing, and then each time just run them and make sure that they are fine. Second one is the same thing, np.random.rand, but here we do a matrix of 2 by 3. And then just run it, yes. Third question, can we create an array of 3 numbers from standard normal distribution? So I say np.random.rand n, and then I want 3 numbers from it. So I get this. Create a matrix of 3 by 2 from standard normal distribution. np.random.rand n, and then I do 3 by 2. Create a random integer number between 5 and 10 inclusive. So I do this, np.random.rand int random integer numbers, yes. So between 5 and 10 inclusive, yes. So since it's inclusive, I'm going to say between 5 and 11, because I won't give number 10 a chance to And I just run this and create an array of five random numbers between 30 and 50 inclusive. I say np.random.rand int, and then so 3 to 50, yes, inclusive. So I'm going to say 30 to 51, and then it's inclusive. Then I want how many numbers? Five numbers. I say five, and then I run it. And yeah, that's it for all the questions that we wanted. Now, what's the output for this? The output for this, so I'm asking Python to np.random.randint without running. We want to guess this. So 10 inclusive, 11 exclusive. So output, so it's going to be like I'm asking Python create a random number between 10 and 10. Between 10 and 10 is only 10. So each time you run this, you get 10. Yes, no matter how many times you run this, you could just run number 10. That was about random numbers. Let's talk about a few method of arrays. Yes. Imagine we create two arrays. One of them is just random numbers between 0 to 8. Yes, I call that R1. So 9 numbers from 0 to 8. And then R2 is this. First of all, again, this space doesn't matter as always. Yes, you can have space or not have the space. R2 equals np.random.randint. So all the random integer numbers between 0 and 99. And I choose 10 of them. So for example, I get these 10 numbers. One of the things that we can do is we can reshape an array with reshape method. So I say, for example, R1 dot, so it was 9 numbers. I can reshape R1 to 3 by 3 formats. I call that R underscore reshaped. I could have called this anything else. You don't have to call it R dot underscore reshape, but it only just makes sense. If you, after like few years, you take a look at your codes, you can just easily understand that R underscore reshaped is the reshaped of R1, yes. Or maybe it's a better idea to call this R1 underscore reshape and this one R1 underscore reshaped, yes. So I run this and then ask Python to show that to me and tells me it's like this. So now I got 3 by 3. Second one, I call this R2 underscore reshaped. And that's going to be R2 dot reshape to 255. 2 rows, 5 columns. So again, what was R2? It was 10 random numbers. And I can reshape 10 in a 2 by 5 format because 10 is divisible by 2 or by 5. And I get this result, yes. So 2 rows and 5 columns. What's the output for this one? R2.reshape. Most likely it's not gonna run, yes, because you can't reshape a matrix of 10 numbers in a 3 by 3 format. So you do that, it tells you cannot reshape an array of size 10 into shape 3 by 3. Yeah, because 10 is not divisible by 3. Okay, let's move on to a few other things. We have maximum, minimum, argmax, and argmin. So for example, we have this R2. Yes, let's take a look at this R2 one more time. It's from 46, 22, 37, 86, 7 to 34, 70, 81, 42. Now, the maximum is 86, the minimum is 2. I can see that, but if I want Python to find the maximum and minimum for me, it's going to do this. R2.max gives us 86. R2.min it gives me 2. Now, let's say, so here, if I want the position, yes, argmax and argmin give the index location for maximum and minimum. So here I know the maximum is 86, but what index is that? 0, 1, 2, 3. But what if my list is rather than 10 numbers is like 10 million numbers? Then I gotta use these things. So argmax gives us the position for that index, and then argmin gives us the position of the element that has the minimum number. So 0, 1, 2, 3, 4, index 5. Yes, 2 is index 5. If you want to check the type of elements inside the array, you use array. Okay, now pause the video, please, and then solve these questions yourself. So we have 4 questions here. Pause the video and solve them. So let's answer these 4 questions. Question number 1, create an array of 15 random integer numbers between 0 and 50 inclusive. Call it my r. So I'm going to call it my underscore r, and then equals. So it's going to be random integer number. So I'm going to say np.random dot rand int, and then I want between 0 and 50. So I'm going to say 51. And then how many numbers do I want? 15. So I say equal comma 15. And then I just run this. I want to make sure I created this correctly. So I'm going to ask my Python, what's my AR? It gives me the answer. Good. Reshape it in a 5 by 3 format. So all I gotta say is this: my underscore AR dot reshape, and then I want it to have 5 by 3. So 5 by 3, and then that's it. Just run that, we get 5 by 3. Find the maximum and minimum. So how do I do that? I say my underscore AR, and then dot max, and then parentheses. I run that 37, and then my underscore AR dot min, and then parentheses, I get 0. And then the position of max and min. So I'm gonna say my underscore AR dot argmax, and then oops, my underscore AR dot argmin, and I get all of these numbers. Position for maximum is 10, position for minimum is index 7. Okay, next topic that we have is indexing and selection. We had this for lists, so it's going to be at the beginning very similar to what we had for the list. However, then we have matrices for 2-dimensionals. It's going to be a little bit different. But let's start with this, creating numbers between 2 and 20, 2 inclusive, 20 exclusive, and then increments of 2. So I get this, and I ask Python to display that to me. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And you want to extract, for example, so here the question is this, for example, extract, let's say, element index 2. So here, what we did is here we create an array of numbers 2 inclusive to 20 exclusive, increment by 2. And then here all we did was to display it. And then element index 2 is this. For selecting the first index in selective second index. Now, let's say you want a chunk of this. For example, elements index 3 to 6. Yes, 6 is exclusive, so 3 to 5. So this one gives us elements index 3, 4, 5, not 6 because 6 here is exclusive, but colon says the meaning of colon is from here to here. Yes, from 3 to 6. So colon essentially means it's exactly like lists. And then, but the first one is inclusive, the second one is exclusive. So here I can say the output for this is going to be elements 0, 1, 2. And I can run this. Yeah. Equivalently, when you start with 0, you don't have to mention that. You can just say colon 3. Or if you want everything from 4 and after that, afterwards, you can say this. You can add a number to all elements of array. We have seen this before. Yes. And it doesn't change however, we didn't change the original value. Yes. Again, in Python, always this is true. Like, let's say you want to, for example, create a variable. Yes. If you want to change this array, yes. So either you can, so we didn't here, we added number 100 to all the elements of this array. It doesn't change the original array. If you want to save the results, all you got to do is to say this. The name of new array, which is, for example, new underscore array. Again, you can call this whatever you want. You can call it cucumber, but here, new underscore array, and then equals r plus 100. Now, whenever you have this equal sign, you're creating something, yes? So new underscore array would be created with all these numbers. And then I can ask Python, what was my R? And this is the R. And then I can ask Python, what was new underscore R? And then this is going to be new underscore R. And then, or you can, if you want to, you don't want to create a new one, you just want to modify the old one, yes? So if you don't want to create a new array, you just want to modify the old array. You can just say, for example, this r equals r plus 100 or times 2, whatever you want to do, yes? So here I'm multiplying that by 2. So I'm just modifying this array. And as you can see, all the elements are now multiplied by 2. So that was indexing when you have only one row. But what if you have a matrix? That's going to be a little bit like more complicated. So just imagine you have a matrix of, let's say, numbers between 0 to 8 and reshape that by in 3 by 3. So if you want, for example, first row, you can do this. It gives you, sorry, second row, yes, index 1, 3, 4, 5. And if you want, for example, out of this, grab element 3. You can say R1 and then bracket 0. Yes. It's just easier if you say it like this, R1, like in brackets, 1 comma 0. So what's the output for this? R2 and 1. So it's going to be row index 2, which is 6, 7, 8, and then column index 1. So it's going to be 7. I can run this and make sure. Yes. If you want to slice a chunk of a matrix, you can use the same things that we had. Yes. For example, here rows 2 and 3 and columns on 2 and 3. Or for example, third row, another like this. Or you can say this. And then the result for this are 1 column. Yes. So that's gonna be rows index 1 and afterward. So index rows index 1 and 2. Here it means all the rows column index 1. Column index 1 is 147. So column index 1. All the rows column index 1 and afterward. Yeah, and in many cases, we want to do conditional selection. For example, we want to do something like this. Let's say uh, like this, numbers between 0 and 10. You can say, for example, all the elements that they are greater than 5. So you say the name of the array, which is ARR, and then inside bracket, you say condition. So that the syntax is this. Syntax, something like this. Array name, bracket, condition. Okay, for example, all the numbers greater than 5 or all the numbers greater than or equal 3. Now let's have a practice here. So given this, or I can make it even more interesting, rather than 3 and 5, I can make it, for example, a little bit bigger. So from -5 to maybe 15. So how many numbers do we have? 20. So I guess do it 4 by 5. Reshape it by. So given this, just give, so it's a 4 by 5. Answer these questions. Yes. Again, please pause the video now and answer these questions yourself. Yes, extract the row index 0, extract column index 2, extract number 0, which is right here, extract only positive elements, extract first and second row, columns index 1 to 3. So please answer these 5 questions yourself. Pause the video and answer them. Okay, let's answer them. So extract row index 0. That's going to be ARR and then row index 0. So you can say 0. Yes. And we get that. Extract column index 2. ARR, bracket, comma, and then column index 2. So if I run this, I get a syntax error because I didn't mention I want all the rows. So I want all the rows, column index 2. So -4, 1, 6, 11. Column index 2 is this. -3, 2, 7, 12. Extract number 0. So number 0 is row index 1, column index 0. Extract only positive numbers. The name of array, bracket, condition. Positive means greater than 0. And I get this. Extract first and second row and columns index 1 to 3. So I'm going to say here, ARR, first and second row. So here I can say first and second row, so in the index 0 and 1. So rows is going to be rows, let's say 0 to 2. 2 is exclusive. Columns index 1, 2, 3. So 1 to 4. Yes. And then that's what we get. Rows index 0 and 1. So these two, and then columns index 1 to 3. So just this part of the from -4, -3, -2, 1, 2, 3. That's exactly what I got here. Okay. I hope you did them correctly. Just a few operations that we can do. Like here, I'm going to create again this array. I'm going to override just that ARR name. I can call it anything else. I don't have to call it ARR. But here I have 0 to 11, step by 1. So 0 to, as always, 11 is exclusive. So 0 to 10. And then I can say, for example, asterisk asterisk 1, that's power, so that's square of these numbers. So I get 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. I can do algebraic operations like add plus 2 times 2. So first it adds 2 to each element and then multiplies by 2. I can create another array, for example, from 10 to 21. Again, 21 is exclusive. And then I can do, let's say, operations here because they have exactly same shape. If we have two arrays of the same shape, we can do this. Yes. Or we can do something like this. R plus 2 R2. So first you multiply 2 by R2. So R2 was this. You multiply them by 2. So that's going to be, last element is going to be 40. And then you add them by R1. So last element is going to be 50 here. Yeah. If we divide by 0 or infinity, we don't get an error. We'll get a warning. Yes. So R was 0 to, let's say, 10. We divide 10 by that. The first one, it gives you infinity. Yes. And then you don't get error. It runs, but you get just warning. Yes. You can do array divided by array. The first one gets not a number because it's 0 divided by 0. But 1 divided by 0 is just infinity. Square root, you can do that. SQRT. Natural log. Natural log of 0 is negative infinity. A few other options that we have. Sum and mean. So sum just adds up all the, again, ARR was this 0 to 10. You add everything. So I'm going to just run this ARR here. Sum of all of the elements, np.sum, the average of all the elements, this. And then if I reshape it in, for example, now R1 is numbers 0 to 14, reshaped in 3 by 5. Shape is 3 by 5. And if I want, for example, sum across the rows, that means sum of the values of columns, yes? I can do this. ARR.sum axis equals 0. So axis 0 is horizontal, so it means across the rows. So it gives us all the rows here, 0, 5, 10, 15, 1, 6, 11, 18. And then across the columns, sum of values in rows, I get this, 10, 35, 60. Yes. So sum of the rows is going to be this. Sum of the columns is going to be this. Now, just as the last exercise that we have right now, just do this. Create a 5 by 4 matrix of numbers 0 to 19. And then, so reshape it in 5 by 4 and then do the same thing. Sum of all the elements, mean of all the elements, sum of rows, sum of the columns. Please pause the video and just do this. Thank you. So the answer would be something like this. I'm going to call this maybe, I don't know, my ARR equals, so NP dot range, and then 0 to 19. So I say 20 because it's inclusive. And then dot reshape 5 by 4. So I run that. I ask Python to display my underscore ARR to make sure that I did everything correctly. And then I answer these 4 questions, yes. So here, what's the sum of all of the elements? Again, it's going to be my np.sum, and then my underscore ARR, and it gives us the sum of everything, 190. Mean of all the elements, np.mean, and then my underscore ARR. Oops, I have a typo, not NM, NP. Then you run it 9.5. What's the sum of the rows? So the name of the array, which is my underscore ARR, and then sum of the rows, I'm going to say dot sum. And then all you got to say is this, axis. So for rows, I'm going to say this. And then, so we get 5 results, which gives me sum of all the elements, sum of rows. So here, I mean sum of across rows. Yes, let's say it across rows. Yes. So 0, 4, 8, 12. Or you can say some of the elements in the first column. Yes. But across rows and then across columns, it's going to be the same thing, but just axis would be 1. Perfect. Okay. And then this one, across rows. Okay, thank you very much, everybody, for listening, and I hope that was useful to you. Thank you and have a wonderful time.